So now let us discuss about the very first theorem in the graph theory. The sum of the degrees of the vertices of a graph is equal to twice the number of its edges. So let G be a graph with n number of vertices and m number of edges. So case 1. So if G is a totally disconnected graph, that means G has no edges at all. In such case, there is nothing to prove. Okay, the left hand side, right hand side both are equal to 0. If G is not a totally disconnected graph, so that means we can see edges there, right? At least one edge. So if E equals to U into V is an edge of G, then while calculating the degrees of U, we will count E once, and to calculate the degree of V, we will count E once, right? If we have a loop E from U to U, in such case, to calculate the degree of U, we will count E twice. Okay, hence each edge will contribute 2 to the sum of the degrees of vertices. Okay, if we have one edge, it will contribute 2 to the degree sum, right? If we have m number of edges, definitely it will contribute 2 into m to the degree sum. Okay, so like that, the sum of the degrees of U for each vertex U belongs to V is 2 into m. So now let me discuss about the corollary of this result. So in any graph G, the number of vertices of odd degree is even. So let me consider a graph G, okay, so which is having n number of vertices and m number of edges, with V as the vertex set and E as the edge set, right? Now let me consider the vertices which are having odd degree. Okay, that is let me consider those elements in V1, and let me consider the vertices which are having even degrees in a set V2. Okay, so then by the above theorem, the sum of the degrees of each vertex is equal to 2 times the number of edges. Okay, now I can split this sum into the sum of elements over V1 and the sum of degree over V2. Okay, so that is equals to 2 times m. Now 2 into m is an even number, and for each V2 belongs to V2, okay, the degree of V2 is an even number. Therefore the sum of even numbers is again an even number. Therefore we must have the sum of degree of V1 must be an even number. So what is V1 here? So for each V1 belongs to V1, I can say that the degree of V1 is an odd number. So I have sum of odd numbers here, and that is an even number. So since for each V1 belongs to V1, the degree of V1 is an odd number, definitely the number of elements in capital V1 must be what? It must be even number. Therefore the number of vertices of odd degree is what? Is an even number.